Uh, Welcome back to this particular talk wherein we are trying to set up a local MLOps dev environment for personal use, and wherein I have three servers, workstations, you can also call them, and on which in part one, wherein we already saw like how can you set up Kubernetes cluster, and in this part, just part two, I'm going to talk about how you can set up a storage class and why you need a storage class. Because, as I said earlier, I'm going to talk about or I'm going to install Kubeflow, and as a prerequisite, Kubeflow needs a default storage class for its various components to work upon, such as WinIO and MySQL and metadata layer. Uh, and and that is a main reason that why we need a storage class to be provisioned as part of this Kubernetes cluster, right? So what exactly a storage class? Just a small background about it. A storage class provides a dynamic provisioning of persistent volumes whenever a PVC claims it. In simple terms, it kind of abstracts the underlying storage and provides a way for admins to describe the classes of storage they offer. And in case you want to know more about this, you can always go to this particular link, which is uh, which is from official Kubernetes documentation, eh, to know more about storage classes, how you can provision them, various provisioners, and various other perspectives, right? So let's go back to our agenda. And for our purpose, I'll be using Rook. Rook is the Rook provides an open source cloud native storage for Kubernetes, while Ceph is the distributed scalable source storage solution. So it's a storage type, and Rook is going to be used to provision Ceph on our bare metal machines, right? So again, in case you want to know more about this, you can refer to this link over here, and this will take you to the official page, official documentation of Rook and Ceph as well, right? So going again back to our agenda, as a prerequisite, it needs a valid Kubernetes cluster, a kubectl installation, which we already did in part one, ability to clone the Rook GitHub repo, and we also need LVM, right? So this is also needed, and then we need raw devices uh, where there should not be any partition and it should not be formatted as well. So we can check whether our worker nodes are actually having any raw device or not. We can do that uh, by using these commands. So let me just uh, broadcast thing, right? So I can use this command lsblk, and this will give me if there is any disk. There seems to be a partition which is not or a disk by the name of SDB, uh, and it seems that it has not been used. Let me just see that in detail, right? So let me just zoom this a bit. Yeah. So yes, so uh, through this check, what you can make sure is that if there is a partition of there is if there is a slice which doesn't have any FS type corresponding to it, then that means that is raw and that can be used. So what Rook or Ceph does it automatically picks it up. It automatically looks for a raw partition, and when we are going to uh, use it, it will automatically use SDP for its purpose, right? So now let's do one thing. Let's install this LVM so that we don't get into any issues of setting up Ceph on raw devices, right? So since our cluster is also or our machines are freshly installed, so I'm not sure whether I have LVM. So let me just install it anyways. So seems I already have LVM, so fair enough. Now I am going to clone the code, and that is needed only on one machine where I'm going to, from where I'm going to access the cluster, and I'm using master for that purpose, right? So let me just create a directory. So I'm just creating a directory by the name, let's say root over here, and then I'm going to get inside this, and I'm then going to clone this. All right, so let's get into this directory now, and there I must have, yeah, another root directory, right? So let's get into that directory, and there are some examples or which are already provided by root. So I'm just going to use those only for my purpose. Sorry for that. I think I just have to, right? And then I'm going to, as a first step, I'm just going to install the CRD. So we are on step 3 in this particular section over here. And I'm going to install all these CRDs, right? So let's do that. You can see all of this. And if I just check my cluster status right now, let's just see. Yeah, so we have a new namespace over here by the name Rook-Ceph, and this container is in container creating here, right? So let's proceed on this. And then as a second step, I'm going to create a cluster. Creates a new config map and a CRD of this kind, right? So now we can just validate the whole thing, whole installation. Right. So since now everything is in running and completed state, so we are done with this. Now let's provision a storage class. So again, I'm going to use the already provided example. We are in Ceph, and there is an example for minimal installation. So that's going to be in CSI, and we're going to create a RBD kind of storage class, right? So let's do that. Now if we check, yeah, so you see a storage class by the name Rook-Ceph block has been created, and it is not still tagged as default, right? So what we can do is we need to have a default kind of storage class, right, as a prerequisite. So let's patch this, and for that we just need to use this particular command over here. Has been named as or it has been patched as default. So we are done with this, and then let's go ahead and proceed on creating Kubeflow setup on this. So as a final step, we are going to install Kubeflow, and so I'm on the Kubeflow documentation page, which is installing Kubeflow, and there if you see it provides two main methods. One is one method is you can either go for a package distribution, or in case you, and there are various options, various vendor sources from which you can get a package distribution such as AWS, Azure, GCP, OpenShift, Arcflow, Aricto. So there are various options as you can see over here. Or the other way is if you want to do it manually, you can go and check their manifests, right? So this is more sort of for advanced users, but this is the method which I preferred, and actually it was pretty straightforward. So if you are done with your basics, if you are ready with your Kubernetes cluster, with your storage class, it's just a matter of few commands to be executed. That's it, right? So let's go there and follow these instructions, right? So if you click on that, it will land on this particular GitHub repo, which is in Kubeflow manifests, right? You can go through this particular README file, and basically it is managed by a work group, and each work group is having a responsibility for different components within Kubeflow, right? So that is how it is. And then there are some official components which are categorized as apps, and then there are some common services which is categorized as common, and then there are some third-party contributed applications which is under this contrib directory, right? So this is just for information. Then what we are going to do is, and as I said earlier, this particular version is Kubeflow 1.5, which is the latest one, and since it is not supporting, it supports Kubernetes versions only up to 1.21. That's why we installed 1.21 only, and then it uses customize the package manager, right? So this have already and that too of a specific version 3.2.0. This I have already downloaded from this particular link, and it's just a simple binary or a CLI. You download it, make it part of your user bins or somehow in your environment, and that should be all what you need. For example, if I just check it out, I already have customized, right? Let's check the version of it. So I'm on, you would have already noticed I'm on my master node. We have already created Kubernetes clusters, so now we don't really have to log in into worker nodes, or for that matter, not even a master node. But as of now, we are using master node as a client as well, right? So from there only we are going to access the cluster and also issue all the commands. So let's check out the version. Yes, we are having 3.2.0, so we are good with that as well, right? And then what we're gonna do next. So I'm just going to clone this code, right? So let me yeah, just a second. So here we go. Again, we can squeeze this. I'm just going to create a directory, or it seems that I've already created a directory by the name of KF over here. Yes. So let me go inside, and then I'll clone the repo. And then the documentation is quite good. It's quite impressive, I would say. It provides two options. One is you can either go for a single command and install all the components under apps and common, or you can install those components individually, right? So in our case, I'll be using this single command, right? And it's pretty straightforward because we are going to use all the components. So that's the reasoning behind it, and we have already created all the prerequisites, right? So it should not be a problem, right? So this is a command which is using customize over here, right? And then let's copy this and try this. All right, so this will start the process. Yeah, so now the resources are getting created. In parallel, let's do a watch over here. So you would see a lot of containers getting created and in container creating, and then they're trying to come up, right? So yeah, like over here, this is cert manager, which is responsible for certificate generation and basically for authorization purposes. Then we have Istio system, Knative eventing. You can check out this documentation for brief, like what exactly for what purpose these components are getting used. Like Istio is used by many Kubeflow components to secure their traffic, enforce network authorization, and implement routing policies. Then we have DAX, which is for it is an open ID connect identity. So you can check this out, right? So all of these components and their roles, you can check this out over here. And meanwhile, what we can do is I can squeeze this a bit more so that this becomes more legible. And let's just see. Just to validate my installation, I'm just checking the relevant pods in relevant namespaces, and usually takes time, a lot of time to get all the pods running. So far we are good. Let's see in Knative serving. So there we see one pod is still in an initializing state. So we have all the PVCs in bound state. Here we have already all the PV also getting created. So it shouldn't be a problem over here. It seems like our storage class is working fine. Maybe we can check with one of these pods. Oh, okay, so it's liveness prob would have failed. Uh, so let's wait for a while. I think it should be fine. All right, now it seems that everything is in running state for this namespace as well. And I think we had a problem in Knative serving as well. Right, so everything is fine now. Maybe we can check across all the namespaces. So you see everything is running state, right, or incompleted. So the jobs have also completed, right? So now I think we are done with our Kubeflow installation. Okay, so since our cluster has been set up, we have set up storage class, we have also installed Kubeflow. Now is the time to check it out if our Kubeflow is working fine or not. So right now I'm on my local client and I've already configured the kubeconfig related stuff to access my cluster from this place. There are certain plugins which I'm using, such as kubectx, to set the context and manage the context, right? So this is the context which I'm right now using live UI, right? And then and we can quickly check like if we have those nodes, yes. And what we can do is now we can try this port forwarding, and so let's do that, right? And then let's go to our browser and then run up my page from this place, localhost 8080. So there I have already the username and configured, which is nothing but you can just check it out over here. Yeah, so this is the default password, right? Maybe we can just try this out. So there you go. So there you have all the whole Kubeflow uh, framework in your local environment on bare metal running fine. So you can go ahead and check, create some experiments in Kubeflow pipelines. Then you can even try these tutorials, right? Create some notebooks, try them out. You can create a new notebook, and yeah, so there's a lot to do here, and which we are going to see in my subsequent videos. So that's it for now. Thanks for bearing me, and I hope you liked it. Please leave comments or feedback for me. Thank you.